So Raspberry Pi, I'm not plugged in. That would be helpful.
You kind of cut off like 5 seconds. You just said a word. Practice.
All right. So Raspberry Pi robot. So Raspberry Pi, kind of like Curtis said about Arduino, like it can be used for a ton of different things. So I'm just going to go over really quickly, like a high-level view of what Raspberry Pi is all about, and then I'm just going to show some examples. So in a nutshell, Raspberry Pi is just basically like an Arduino, except 3 or 4 levels of abstraction up the chain, right? So it's Linux on a single chip. It was designed for education, so the idea behind it was like, hey, if you have a keyboard, a mouse, and a display, you should be able to have a computer that a kid can open up and start running and start programming on for the least amount of money possible. And so you can get a Raspberry Pi, that'll plug into an HDMI and a mouse and a keyboard, and you can get the whole thing, you can get the computer part of it for about $25. And so that's a lot of their aim for it. So it's actually not specifically made as like a hardware hacking tool by any means, but it happens to also be really good for that. And the thing that I love about Raspberry Pi so far is that it looks and feels a lot like just a normal Linux box. And for someone coming from the server side kind of software world, it's really nice just to have a set of tools that already work. Like if I want to find out a way to say like, oh, this thing on my device needs to run every Wednesday at 4 o'clock. It's like, oh, I can just use a cron job. Cron jobs just work. It's just part of Linux. It's already on there. So how similar is it? Well, like the first time you turn it on, if you just run Ruby-V, you'll find that it has a version of Ruby on it, it has a version of Python on it. You can apt-get install other stuff to your taste. It also has a program on it called SonicPi, which is a way to express music in text. And so you program music, very similar to Ben Eggett's talk from Mount West RubyConf this year. The people behind SonicPi have some really interesting ideas, and it's extremely powerful. So really fun thing to play around with. I didn't do any of those things though, really. Another reason that makes it really fun to work on is that it has a great community behind it. This is very similar to like why I love working on Ruby, for instance, is that there's this great and very welcoming community. So if you look up Raspberry Pi, for instance, like the main homepage has a lobster on it. Pretty much feel like I'm in Tenderlove's main living room or something like that at this point. And like, I don't know what these guys are, what they're doing, but they look pretty approachable, pretty nice guys. And then if that wasn't enough, there's another organization called Pi Wars, and this is going to be the second Pi Wars, where it's like, if you've ever seen like any of those robotics competitions, where people make robots that try to achieve different kinds of tasks, those are super cool, and I've always been so envious of people who participate in those kinds of things. And then I found out that they have like one that's specifically for Raspberry Pi enthusiasts, and it's just like total amateur hour. Like there's a lot of really dumb robots there and a lot of really cool robots there, and everyone has a blast. And I'm like, this sounds basically like a Ruby conference, but with robots. So Robot RubyConf, like that's amazing. So so that sounds like a ton of fun. So what can we do with this thing once we get it up and running? So I've done 2 projects so far. The first one was out of necessity for my own sanity. So I have a 4-year-old son, and he got into the habit of waking up at 5:30 in the morning and coming downstairs, and he'd walk up next to my bed very quietly, but then he'd come up and he'd put his fingers on my eyelids and open my eye like this. And his first words every morning were, "Chocolate milk?" And so I was trying to find a way to like set some rules about when it's appropriate to wake up and come downstairs and when he needs to stay in his room. And I didn't feel like we could just make a rule that was like, if you come downstairs before it's time, then you're going into timeout, because he doesn't know what time it is. Like, it's the springtime in Utah, and every day it's light at a different time, and then it's like cloudy one day and it's light at a different time. He doesn't know, and he can't read a clock. So I wanted to find a clock for him, and we bought one off of Amazon that would turn this light on at a certain time in the morning. But the only way you could set the time is by going to his room at that time in the morning and pushing and holding a button down for 20 seconds. And guess who figured out how to reset the time on day 2 of his new clock? So I was like, man, I really need a way to like be able to set the time easily and not let you set the time easily. So Raspberry Pi to the rescue. So my favorite part about this project is I got my son, the 4-year-old, got to do the Dremel. He was very excited. And we just got like a little wooden box that he had as part of a toy. We cut out a piece of plexiglass, screwed it on the top. He got to like totally help with all the different things. I got him to help with soldering a little bit. My wife was very nervous. I was a little bit nervous, but not too bad. And basically, you just put together a little project that's just a Raspberry Pi. It has a Wi-Fi adapter, so I can log into it remotely and change the time. Like, no, 7 o'clock's not late enough this morning. It needs to be 7:30. And then it has these wires coming off of it that are just hooked to a couple of really bright LEDs. So it has a red LED, and at 5 a.m., that red LED turns on, and we've taught him red means stay in bed. And then at 7 o'clock, the red LED turns off, and a big bright green LED turns on. And the rules are now, if you come downstairs before your light is green, then you have to have a timeout. If you come down after the light is green, you will definitely get chocolate milk every single day. And so this has like actually worked. And is probably one of the most useful pieces of software I've ever produced in my life. So that one was a lot of fun, but not very exciting as a demo because all that happens is one light turns on and then another light turns on. And so then I thought, you know, Pi Wars, how cool is that? I want to make a robot. I want to make something that moves. So I looked around my house, and I had this really crappy RC car that we bought at Walmart for $9 for my son for Christmas that he's not really driving anymore these days. So I was like, how hard could that be to hack? So dive in a little bit. If you open up the back of the transmitter, it just has this board. But right away, you notice a few things like those rocker switches on the front of it. Normally, you actually just touch these 2 different touch buttons, one for forwards and backwards, one for left and right. And I'm like, so it just has 4 signals. And conveniently enough, there's these like really easy to use soldering points that you can connect to right next to each of those buttons. So I was like, well, what happens if you connect to those buttons? So the first thing you do on this kind of project is you break something. So I broke the main, this is where the main pin went down to like the battery compartment to connect to the positive end of the battery. Broke that. So then I had to like do this really crazy, messy soldering job to reconnect this part of the power terminal to that part of the power terminal and my wire to it. And then I was really worried it was going to break, so I put hot glue all over it. Still works. The negative terminal went a lot better. Then I soldered a couple of pins to the places on the board that looked like they were connected to this button. And the top button, it's kind of hard to see, but the trace kind of comes here to the left and comes down and then comes over. And I just kind of touched a 5-volt wire to a few different places on the board to figure out what was connected to what. And figured out pretty quickly. Then I did the same thing for left and right. Now the whole thing looks like this. And there's a lot of wires, but I wrote down on a little piece of card for myself, like, blue is backwards, etc. And then it was not too bad. Then Raspberry Pi community, once again, has my back. And there's a page somewhere on the internet which is just like, here's a guide to all the pins on the Raspberry Pi, what each one can and can't do. And if you happen to hold up your Raspberry Pi right next to it, they line up perfectly so that I stop connecting things to the wrong things and breaking things. So I do all of that. And then once I turn my Raspberry Pi on, the way I can interact with this, there's various ways to interact with these GPIO pins. But now that I have a pin on my Raspberry Pi connected to this little transmitter, I can just say, hey, I want to access pin 17. Write 17 to this file. And that says, start granting access. Then I say, I want your GPIO 17 direction to be out. And I want the value of GPIO 17 to be off. And then I want it to be on. And when you say this thing, then your car starts moving, and it's magic. And so you get way too excited about this stuff, or at least I get way too excited about this stuff. But now it's demo time. So, oh, someone's downstairs. Does anyone want to go downstairs? Thanks, Johnny. So, if anyone, I'm going to give you fair warning. In a few minutes, I'm going to open up access to this thing, and anyone can drive it if they want to. The only thing you need installed is Elixir, because that happens to be the code that's running on there. So if you want to, you can just brew install Elixir.
I already have
And
Done.
so I'll give out Wi-Fi credentials in a minute after my demo's over, maybe before, so I can blame it on you guys if this goes terribly wrong. That might have been a good idea. So here's the truck now. It just stripped off a bunch of stuff off the top, mostly to save weight, because this thing is really slow. And so you can see it still has like the main receiver board on it. I haven't really touched that at all. I've done a little bit of experimentation of trying to mount the Raspberry Pi on here. But in order to send enough power to the motor and to the steering relay thing, solenoid, you actually need like separate circuitry. And I've been working on it, but it's a little bit dodgy at the moment. So tonight we're just going to do remote control version. And one nice thing about having this all wired up to the remote control, sorry, it's kind of hard to see, this is low, but I still have all these buttons that are on it, right? So I can actually just be like, drive forward a little bit. So if it gets into a really bad place, I can still kind of use these buttons to get access to it as well. So let's see how terribly this goes. So I'm going to jump onto this Pi-Fi network, which just because the likelihood of the work Wi-Fi actually working for this is basically nothing. So, so I'm going to jump on there. I'm going to find out what IP address the Pi has right now. Just look at my attached devices. So my Pi 3 is at 192.168.1.3. So now I just am going to take a couple of steps here. So first, I'm going to edit my etc hosts file. And I'm going to say that's normally your address, but tonight this is your address. Okay. So now I just need to make sure that my computer knows that the right host name because of the way that Elixir connects to it. So I do that much, and now I come back over here.
You might want to get out of full screen. It's cropping like that. Oh, there you go.
It's kind of weird that it cuts off near the top. Maybe I'll take it out of full screen and actually do something like this, just so it's a little bit easier to see. Something like that. So, so what I'm going to do is I'm going to start an Elixir shell. This is just like IRB. I'm going to give my local copy of Elixir a short name or an S name. I'm going to say this is my laptop. I have to have this secret that's shared between me and the copy of Elixir running on that so that they can encrypt the data that goes between them. And then I'm going to tell my Elixir shell, I don't really actually want you to start up and run your own program. I want you to open a remote shell on the copy of Elixir that's running on this thing. So, fingers, oh my gosh, it worked. All right, so, so now I have this copy of Erlang OTP17 that's running on this machine, which is plugged into this other thing, which is talking over a radio wave to that thing over there. And I can say driver.forward. Anyone want to take bets on whether or not this works? Yeah! Driver desktop! All right, I'm going to have to drive back in here a little bit. Sorry, buddy. I'm not a very good driver, especially after I already broke your controller. All right, so if anyone wants to connect to this thing, you can also issue these driver commands. And last thing I'm going to show really quick is a great way to scare small children, cats, and dogs, which is write a little program that randomly every second picks a different direction to drive and tries to drive. Oh, it's called wanderer.resume. Sorry. Wanderer.resume, and now it will just randomly drive around, and it will probably get stuck somewhere here in a minute. When children start to cry, you run wanderer.pause to tell it to like stop running for a little while. So if anyone wants to connect to this, so jump on the Wi-Fi network that's called Pi-Fi, and the password is Pi-Fi. It had to be 8 characters long, all lowercase, because we're programmers, we don't use uppercase. What are we, animals around here? And so Pi-Fi, and then this is the exact command. You can just run this from your terminal, and as long as your cookie is Pi, and you have your own name, and it knows that Pi 3 is actually that IP address, then you should be able to connect to it and start to issue driver commands The list of driver commands, I'll just tap this so you can see. So you can do back left, back right, backward, forward, left, right, stop. So it's a race now. Who's going to get connected to it and actually start issuing some commands?
So what is the IP address?
192.168.something. 1.3. 1.3. Yes, 1.3.
And you said like last name is your computer name?
You can just make it whatever. It just, the Erlang node wants to know what to call itself when it talks to the other Erlang node.
Oh, no.
Heyo! We have flight. All right, so outcomes of this whole talk, you can waste a lot of time on the Raspberry Pi. You can also make children cry, and you might be able to get yourself a few hours of sleep back on a daily basis. But really what I hope comes out of all this is just that it's been a long time since I wrote a piece of code that when I ran it, like I could see and hear and touch something that happened as a result of that. And other kinds of code are beautiful and amazing in their own ways, but this is kind of, it feels unique and different to me. And I spent, about probably $30 in electronic stuff and $10 on a cheap RC car, and it works. So, oh wow, that's interesting.
They're hacking it.
Laptop at MVP. Fight back. Just kidding. I don't know how to do that.
I bumped you
up. But anyway, so if anyone is interested in this kind of stuff, ping me on the Slack group or the URUG mailing list, and let's make some robots together. The end.
All right. Mike.
Yes.
All you really have to do is just push it into production. You'll see it and hear it building almost immediately.
It's true. Not very good things. Instead of children crying, it will be me crying.
We leave that on the entire time, man.
Is it just wandering still?
I said
it gets.
Stuck in the corner.
So this is an interesting phenomenon. You would think that if all the movement was random, that its chances of getting stuck somewhere would be fairly random, or that its likelihood of getting out of being stuck would be fairly random. But it seems to not be the case. So clearly I don't understand statistics very well, because it does tend to get stuck against something, and then it'll kind of move away a little bit, but come back. So there's definitely nothing in the programming. The programming is just like, pick a direction, wait 1 second, pick another direction. That's all it does. So who knows? Maybe this is the beginning of Skynet right here.
Like that robot's game that we
Can you get in?
Huh?
That robots game that we played for a couple of weeks.
Oh yeah.
That was like kind of similar. Like a few things I would try doing is like apparently randomly turning doesn't result in anything other than I don't know.
Yeah, it is interesting when you write code for robots. So when you write code on a Rails app, and eventually some user is going to do something that you never planned on. They're going to send you some really weird input, like you're expecting some JSON and you get a CSV or something like that. But in reality, when you try to write code that interacts with the real world is even crazier and more random than your users are.
You expect JSON to get water.
Yeah. Or I have this sensor that's supposed to read my distance, and it just told me -5 million because it hit a boundary case. And so you're like, well, now my code thinks that I just moved 5 million miles backwards or something. It's like, it's really weird to deal with, but it's also really fun. So anyway, if anyone's interested, hit me up, and we will make robots together, and maybe we'll go to Pi Wars. We'll have a Utah Valley team to represent us in Pi Wars.
Where is it? BattleBot.
BattleBot, yeah.
This year Pi Wars is in London.
Okay.
So that would be really cool if we could get to go there. So my long-term ambition is to win BattleBots with a machine that has no remote control other than start battle, right? I want to basically say, all y'all suck at driving your machines, and if it drives itself, it does better than you. So that's unlikely to happen, but I'm ambitious because I'm an engineer. So, all right, end of the presentation, and we'll make room for Quentin.